Hello Bhavna, am I audible?
Hello, sir. Yes.
Alright, so today we will do the multiplication product of the vector and we are done with this complete chapter. Okay, so I'll just share my whiteboard. Okay, Bhavna, so the topic is multiplication of vectors. Okay, multiplication of vectors. Okay, are of two types. One is scalar, a scalar product, uh, which is also known as a dot product. Okay, scalar is because of product is scalar. Whatever the product you are going to get in this case, there the product will be coming out as only a scalar quantity. Comes with only magnitude. Represented by dot. Product represented by dot. How it looks like A dot B. Okay. A representation of dot product. Another type is a vector product. Known as cross product. Okay. Product comes out as a vector quantity. Multiplication is represented by cross. What does this mean? That when you do A cross B, you are going some vector C. Okay, this vector will be have is a vector quantity. That's why this is a vector product. Here, if you do A dot B, you will be adding some vector C, which where only you are going to get the magnitude. Okay? Only magnitude. That's the basic intro of the multiplication of vectors. Clear?
Yes, sir.
Okay. I'll just move to the new page, fresh page. So here we will discuss only about the scalar product. Scalar product is basically multiplication of vectors magnitude.
So I can't see.
Wait, okay, I think you can't see. It is showing, you can see. Okay, wait. Can you see this on another page? Can you see this normal? I go back to previous page. Come back to this page. I'm in okay. Bhavna, can you see this now?
No, sir.
Uh, okay,
Let me rejoin again.
okay, sure.
I can see it, sir.
I could see that. Okay. So what we can do simply, okay. So what is scalar product? Scalar product is, this is just a layman definition. Okay. What does this mean? Scalar product is basically multiplication of vectors magnitude which are in the same direction. Which are in the same direction. Okay. Although this is not an official statement, just to remember or you can understand better. Assume, Bhavna, I'm giving you these two different vectors. Okay? Let's say these two are the vectors, and I say get me the dot product of these two vectors. So how we should approach this problem? Okay, let's go with the definition first and identify what should be the actual dot product for this one. If you see, Bhavna, let's say there's an angle between them, and this is a vector A, this is a vector. You know that I want A dot B, is it? I need
Yes,
some
sir.
value for this. Okay, let's go with the magnitude. What does the what does the definition says? Definition says the scalar product is nothing but multiplication of vector magnitude. It means I have some magnitude. Let's say the magnitude of A is A and B is B. Okay, is it only the magnitude? No, magnitude which are in the same direction. What does this mean? I can only multiply the vectors magnitude of vector, like vectors magnitude part, which is in the same direction. Okay, both should align in the same direction. Understood?
Yes, sir.
So can I say, like, is it look? Is it the case that both are in the same direction?
Yes, sir.
How? No. This is going in this direction. This is going in this direction. Direction is different, right? Look at this. The direction of B and A are different, and as per the definition, I can only multiply the magnitude which are in the same direction. Mean to say, if either this and this should be happen, either this and this should be happen. So what I should do? Look at this. They are not in the same direction.
Okay.
Understood this part? So which part I have to
Yes.
multiply? The part which are having the same direction. Yeah. Okay, that's fine. So how I should approach this problem? Bhavana, we have already studied the resolution of vector, right?
Yes.
In that, we know that if I have given this kind of vector, I know it can be resolved into two. One is in the perpendicular component. Okay, this is your perpendicular component, and this is your downside component. Let's make it. This is your perpendicular component, okay, and this is your base component. This side. Let's make it this side. So, mm, assume here this is your base component. Okay? So Bhavna, look, if which component of A, if I ask you, what is the part of A which is projected on B, like which is what is the part of A which is on along with the A? So can I say only this is the part which is along with the A,
Yes.
right? Because how we write a vector, I generally say if this is the direction and the constraint is X, this is Y, so I can say the vector is lying here, right? And we say that this vector is nothing but X times of I plus Y times of J. This is how we make a vector out of it. Now, if I have to just look, what is the part of this vector which is on the x? It is nothing but the direction, like the length, right? Point to point, this to this, you just join it. So, can you tell me, Bhavana, what is this length? The x part. Can you calculate this length? Look, don't say that a because we are not sure whether a and b are equal. There might be case that a can be this much length, right? In the same direction. And there may be possibilities that a can have only this small length. A can be having anything. Okay. So I'm just interested in what is the length of B when projected on A. Okay. So wanna just let me know. It's a very easy. I think it's not that much complicated. Hello, Bhavna, are you solving it? Hello, Bhavna. Is it audible? Am I audible?
Hello, sir.
Yeah. Are you solving this part?
Yes, sir.
It's not that difficult to. You should not be taking much time on this part. This is just a resolution of vector.
So you're asking for length of A.
No, no, I'm not asking for length of A. I'm asking the length of B, which is along with A. Okay, because you can see the whole length is not with B. The whole of B's length is not along with A. I'm just asking the length, the portion of B's length which is along with A. Understood? This is what the resolution is vector is all about.
Is it the minus of that length thing?
No, why it will be minus of that? Okay, what I am asking for? I'm asking for this length, right?
Yes.
I'm asking for this length. Is it?
Yeah.
Isn't it easy if you just draw a small perpendicular and you will say, okay, I can see it is like a right angle triangle. I need this base. What is the cos theta? Base upon hypotenuse. What is hypotenuse? That is B magnitude.
Yes.
Got the x? So what is the magnitude, like what is the dot product finally? That is A, B, A,
A.
the A's
Yeah.
product. Okay, because look, they're in the same direction. I have got it. I just need the vectors which are in the same direction and then I will multiply it. Okay.
Okay, sir.
So if you do this, what happens? A dot, okay, plus like multiply with so normal multiply. You just have to do normal multiply. Basically kind of dot, okay? B this. Okay, I and I. That is fine. And that is A B cos theta. Remove this here. It's not the way actually. This is direct thing, okay? I'll write here. A B and cos theta. Yeah. This is what the solution is. This is the way which I give you definition. On the basis of this we have solved. In general, very simple. As per the book definition and all, they say that uh, dot product is given by dot product is given by product of magnitude of vector and cosine of the angle between them. And cosine of the angle between. This is what the definition in the books given, like cosine of angle between them. What does this say? It is again the same thing. Okay, just definition is kind of A dot B I can give as product of magnitude. A magnitude, B magnitude, just simple multiply. And the cosine angle. Instead of cos angle, just multiply. This is what the definition says that, okay? But actually
Okay,
we
sir.
don't get the crux of the dot product by using this definition. So that's why I have just gave you this layman so that you can understand what actually the cross product is, okay? So what is the no, dot product is? What is the dot product? Any two vectors are given to you, any two random vectors are given to you. Okay, you just have to multiply. Okay, you just have to multiply the vectors which are in the same direction. Okay? But if like if assume you are given this and this, do you need to make any component? No, because they are in the same direction. You can simply say that A magnitude, B
Yes.
magnitude. This is the thing. But here they are not in the same. So what are the two possibilities? One possibility is there. Assume you just take this direction. Okay? You are taking this as a base direction. So take its component on this. What is the component? What is the part of this vector on this? You can simply say this is the part of this vector on this. Okay. Another way is, okay, assume this to be your main base. You have to identify which should be the main base. Okay. So yeah, if it is in the main base, this will come out this side. Understood this thing?
Yes, sir.
Okay. So you know one thing, that A magnitude at least will be there, B magnitude at least will be there. When I go from this to this cos theta will be there, right? So the point is, will it be there when I go from here to here also, or it is just for the case that if you are going from here to here, it will be cos theta. If you are going from here to here, will it change or it will remain same? What do you think, Bhavna? Will it be the same or it will change? Like if I just change the direction, let's say I'm saying I'm taking this as a direction. So for this one, I have this as a main magnet. I'm going from, I'm taking its component on here. So you have got some value, let's say this thing. Now I'm trying to do the reverse. I'm taking this as my base direction. Okay, so I said B. If I'm going A's, I'm taking A's on this. Will it be the same or it will different?
So it will be same, right?
Right? It will be same because what is the A's component is if this again if you see this is the base, right? Just draw perpendicular.
Yes.
If you draw the perpendicular again, you can say this is x, this is hypotenuse, x is equals to x by h is equals to cos theta. Because theta is same, right? It is not varying. So either way you go from here to here. The whatever you are going to get is magnitude multiplied by the cos theta. It will come out as, so finally it will be AB's cos theta. Okay. So you can
Okay.
remember the formula directly, AB cos theta. Clear?
Yes.
Okay. So if I ask you, Bhavna, what is the dot product of A dot, like I dot I?
One.
Yeah, I dot I will come out as one. The reason is very simple. They both are. Let's say if I look for I, this is J, K, and this is I. You know they both are in the same direction, right? So I will simply multiply their magnitude one into one. Got my point? For j into j1 k into k1. That is fine. Acha, apart from this, if I do I into j, what I am going to get? Sorry, it should be dot product. Okay. These are one. This is good. But if I do comma I dot j, what I am supposed to get? Can you tell me the value now?
The zero.
The zero. The reason is, look, this is a, right? Let's say this is I, and I'm asking you, I have to multiply each components which are in the same line. Okay, let's say I'm taking this as my main line. So I know its magnitude will be one itself, right? Okay. Now I have to multiply with the others magnitude which are on this. If you see carefully, this is very straight, right? So if you just put a torch from the top, you will just see a point over here. Point mean to say length is zero. Multiply this, you get the answer. Okay. If you go with the formula, this is A, this is B. There's an angle that is 90 degrees, so AB cos 90 degree comes out 0. Is that clear? Basically, when you do B cos theta,
Yes.
you are taking its component. It's how much its component is on this. If you see what is the length, basically we generally do it like this way, right? This is the point, this is the vector. So what is the length? This is the length.
Yeah.
You are just decreasing the point, so you can see that your length is very decreasing. Doesn't matter. It is a even it is a kind of very big. Okay, where I can
Okay, sir.
maybe even you can see this goes a very high length. If the angle is very high, you can see that at this point you are just getting this much angle. Okay? So if you can see, if I just make it very straight, in some case the it will aligning with the point to point. Like this might be the length. Let's make a straight line out of it. You can see if it's a straight line, you can simply say its initial and final point are lying in the same point. If that is the case, then length comes out as zero. Okay? That is it.
Okay.
Clear? Okay, so our final way to calculate a dot product. Look, this is the way in between two. Now I'm another giving another way. Okay, from here you can also say that if I had to calculate the angle between them, I can simply do that A dot B divided by A magnitude B magnitude, right? This is another way. But okay, that is fine. You can calculate this. This is also you can calculate it. Earlier we used to calculate this by using this formula. But how I will be calculating this? You can calculate this thing by if you are given a vector as ax I plus okay, abc x y z. Not p, q, r. Okay, let's say you are given a vector 1 as a vector I cap plus b vector j cap plus c vector k cap. Another vector is given as xi plus not xy. Let's take it as pqr, pi plus qj, mno. Let's take. It's better. M times of I plus n times of j plus k times of o. But it will decline 0, which ijk k is already used. A B C E F C X I Z I. Let's say this is xi plus y of j plus z of t. Okay, this is just a variable for me. I have to multiply. How I can multiply? How? You know, a very simple idea we already know. We are very well aware of it. That is what is that? Simply, you have to multiply, right? This is what it says. Simple. Just do a simple multiplication. Guys. All the
X
representation.
plus BY plus
Yeah. So here,
CZ.
what you are going to get, you can see if these kind of multiplication you are getting. What we used to do, we used to take any first, and I will multiply it with the all these three, right?
Yeah.
And add each of them. So you can see when I do this for this I will be just having xi. The rest will be I into j I
Zero.
dot k, right? Right. Basically, yeah. Yeah, it will be I dot j, I dot j, and I dot k. And you know that apart from this, like for dot product are only constant for, like have some value for the same line, right? You know I,
Yes.
j and k all are perpendicular. So if you do the dot product of any two x's, you will be getting zero. So can I say that if I do for I with all three, I will only get as a times of x, and I dot I will become one, right? The rest
Yes.
will come up as 0 plus 0. Can I say this?
Yes.
Okay, let's do for bj. You know the bj start with xi. So j and I, it will become 0 plus j and j. So here it will give some value, and then rest will be again 0. Same I can do for here. Just look at these questions and let me know if you are clear with this thing. And the last will be only c times of j. Clear?
Yes.
So simply, if anyhow you are given a dot product, what you can do is just multiply I b to p, like j to j and k to k. Okay, and you will get the answer of v1 dot
Okay.
v2. This is what the scalar product is all about. Okay,
Okay.
how we could calculate. That is fine. Okay, Bhavna, so let's solve it one problem. Hmm, you are given a vector, given two vectors. Uh, v1 is equals to 2i plus 3j minus mk, and you have another vector is what it can be, I plus minus 2, okay, I plus 3k, 3 times of j, uh, plus 2k. Okay, this is what your answer is. 9 to 11. Like make it full. Okay, this is the condition where v1 and v2 are perpendicular to each other. Calculate m. Okay, you have to calculate the value of m. You are given some particular condition. On the basis of that, figure out what is the value for m.
So is it 7?
Is it 7? Wait, 2, 12, 14. Yeah, it's a 7. So, Bhavna, we are done with the cross product or dot product basically. Okay, what's the time right now? 6 to 7 minutes are left, and we can't do the vector product. Okay, let's discuss more about the dot product itself. Special cases and yeah, special cases. Basically. What are those? The first one is if um, a1 a dot b is 0. So some conditions are there. Either a0 b, either b is 0 or both are 0, either or both are 0, a is equals to 0 and then b is equals to 0. Okay, these conditions are there. If a is also not equals to 0, b is also not equals to 0, then again a possibility comes out that theta between them is 90 degree. Clear?
Okay, sir.
Or this can also be true earlier also. Might be, it can be the case that this both are 0 also, either of them is 0 also, but the angle is 90 degree. So that is the what it means. If theta is 0, so a dot b is simply ab. That's it. Another is cos of theta is also given by a dot b divided by, I just need the magnitude of a and b, right?
Yes.
So this comes out as a, yeah, that's fine actually. A dot. This is how you can calculate the cos theta.
So can you do one problem regarding this?
Which part? The second or third
This
part, right?
formula, yeah, cos theta is equals to.
Yeah. Okay. 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 Let's do the upper this problem itself. Okay. So let's do it. Second problem. You are given two vectors. Two vectors I can think or something. Let's say two vectors. A is equals to I plus 6j minus k. Okay. And B I can take as 2 times of j plus 3 times of, this is I, 3 times of k plus um, minus 2 times of I. Okay, I have just reversed it, I and j position, so you can just, yeah, calculate the angle between them. Okay, angle between them. Look, if this is given, the magnitude you can calculate very easy, right? The part is calculating a dot b. If I have magnitude and angle, I can simply calculate a dot b by using a b of cos theta. But here they are saying just calculate this. So how you are going to get to calculate? You know how to calculate this part. We have two methods to calculate this. One is this way. Another way is a proper open everyone and just multiply them, right? So how I am going to get calculate a dot b? I said you are given a proper vector. What does this mean? You have to multiply. Multiply I with its I component. I multiplied by minus 2, this will be written by minus 2. 6 into j is 12. Minus k into 2. No, this minus k into 3. So this will result in 3 minus 3. So what I have got overall, this comes out as 7. Clear?
Okay, sir.
Look, in general, vectors, we are not given magnitude. If it is not given, you have to write only unit. It might be any unit. When you are solving a problem, if units are not given, just write some unit. Okay, this unit you have to write. If it is given, you can write meter and whatever it is. Okay, so you can see I have calculated it. What I needed to calculate cos theta, what it should be, a dot b, okay, divided by a and b. What is a dot b? That is 7. Okay, what is a's magnitude? I square, so that comes out as 1, plus 6 square is 36, plus 1 square again 1, under root 38. This is a. What is b? 4 plus 9 plus 4, 9. So this comes out as how much? 17. I hope so. Yeah, it's a 17. So you can just multiply both of them. What you are going to get is 38 into 17. So this is what your answer is all about. I have taken very random values, so we can't we are not getting a perfect square or something from where I can say the theta comes out as and this and this. You have to just solve it, okay? And when you put into the calculator, you will be getting some value, some angle of theta. Clear?
Okay, sir.
Any doubt? Any kind of confusion?
No, sir.
So now, wait, where is not from here? We are nearly ending to the chapter. Okay, I will share you a sheet along with this part today. What you can do
Oh,
is start solving the problem from there. If you don't have any
okay, sir.
problem like from your side, you can start solving from the top. Okay, at least, and by the time we okay in the next tomorrow's class, we will end the complete chapter, so you can do all the problems from that sheet. Okay.
Okay, sir.
Wait, I'll share this one first. Okay, yeah, I'll share it. Okay, when you get the PPT, along with that PPT, you will be getting this sheet also. Okay,
Okay, sir.
all right. So that's all for the today's class. If any doubt is there, let me know, or else I can end the session by this.
No, sir. Okay, sir.